In this video, we're going to look at solving equations. So far, we've been analyzing the graphs of our degree 3 and degree 4 polynomials. And so what we'll focus on today is how do we solve these equations without creating a graph, and how can we find the exact solutions if the x-intercepts are decimal values that we wouldn't be able to fully interpret just by looking at them on a graphing calculator. So just as a reminder, we've done several strategies with quadratic equations in the past, right? Those x squared equations that make parabolas. And just to jog your memory, a few ways we did that was by graphing. Let's start with that. We start with graphing just like we did now in recent lessons, to where we look at the graph, we investigate where the x-intercepts are and say that's where our real solutions are located. But we've also done this in two other ways. One of those, a big one, was factoring, which remember is breaking a polynomial down into factors that multiply back to it. And then the third strategy that we used with quadratics was the quadratic formula, which I'll go ahead and write on here because we'll end up using that later. That is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, where we just figure out our coefficient values, a, b, and c, substitute them into our formula, and simplify from there to get our two results from the plus or minus sign. So none of this is new because we've done this before, but we're no longer solving quadratic equations. We're going to bump it up to cubic and quartic, so degree 3 and degree 4. Good news is a lot of these strategies can still be used. So let's briefly look at this. We have a few examples, but before that, we are going to look here. Remind ourselves some things. When we solve equations, we always make sure they equal 0 because x-intercepts, if we're on the x-axis, the y value has to be 0. It's going to help if you write everything in descending order. So start with your highest exponent and work your way down. And then factoring is our best bet. Factoring is actually the most direct method we could use, even though it's not something we always prefer. So as far as factoring goes, that is just rewriting as multiplication. Different strategies we might use. Greatest common factor is a good one to look for. Do all terms have something in common? So we'll check for that and bring it out if there is one. So maybe it's an x, maybe it's a number. We'll just have to see. Split the middle. That was our factoring, which involved finding two numbers. So to break our middle term up and then end up with 4 terms instead. So split the middle, we look for that when we have 3 terms. And then with difference of squares, that is when we have a 2-term polynomial, and what we've seen before is this a squared minus b squared. And we have a very simple factoring for that. It's just a plus b and a minus b, where the parentheses are the same except for the plus sign and the minus sign. Just to remind you, when we use this one, a equals the square root of the first term, and b equals the square root of the second term. Okay? So an example of that would be x squared minus 49. If we wanted to factor this, because we know the square root of each, we would say both sets of parentheses start with the square root of the first term. So the square root of x squared is just x. One parentheses has one factor has a plus, the other has a minus. And then we take the square root of our second term, 49. Square root of that is 7. So both parentheses end with 7. And right there we have our factors very easily. What we're going to see today is the sum and difference of cubes, okay? because we've now worked with degree 3 polynomials. So if you look closely here, with these, we have two options. We can either have a scenario where we have two terms with a plus sign or two terms with a minus sign. And no matter which one we're working with, the formula is very similar. The only thing that actually changes is where we have a plus or a minus sign, but everything else works the same. So with these, we use them if we see x cubed, if we have a binomial that involves x to the third. And so in this case, we could look at an example like this one. Start with x to the third, and I'm going to put a number here, 27, for a reason. Because in this first formula with difference of squares, we said we take the square root of our terms. Well, here we're going to do what's called the cube root of our terms. So I'm going to have you think about square roots. The square root of 49 is 7, because 7 times another 7 gives us 49. And a cube root is going to work very similarly to that. Instead of just having one number times itself, we need a third of that number. So it would be a value times itself again. And so as we look at this formula here, I see that there's a plus sign, so I am using this factorization. And I see the first parentheses start with a plus b. Well, a is going to be the cube root of our first term. Now, don't overcomplicate that. If the square root of x squared is just x, the cube root of x to the third is just x. So we can expect that for now. We're going to keep things kind of basic as we learn it. Now, the cube root of 27, we're going to have to think about a number times itself again. So you could guess, you could start with 1 and say, what's 1 times 1 times 1? Then you could try 2 times 2 times 2. And when you try 3 times 3 times 3, it ends up being that. However, if you have a calculator that has a function like this, we could type in the cube root of 27, and we know that's going to equal 3. And if you use the Desmos calculator, the scientific calculator, there is an option for that. It has a little n right here in the tail. And we just tell it that we want a 3 for cube root. So that's how we get started. I take the cube root of x cubed and get x, the cube root of 27 to get 3. And I put a plus sign in the middle because that's what the formula says I should. And if you look very closely here, by taking the cube root of x cubed, we have found a. By taking the cube root of 27, we just found b. And so when we finish this other factor, notice it starts with a squared. Well, if a is x, we're going to have x squared. And then the formula has a minus sign, so we keep that. And then it says a times b. So a is x, b is 3. And at the end, it says plus b squared, so we get plus. And then b is 3, so we put 3 squared. And if you look again, that gives us a squared here minus ab plus b squared, just like the formula says. And I'll show you how to work with that in a moment, but using a formula shouldn't be too bad. We just need to know what it is that we're plugging in. Okay, so watch those signs and everything should be fine. Now, after we factor, we set our equations equal to 0, because if we're thinking in terms of x-intercepts, these are called zeros because we find them when the y value is equal to 0. And if we can't do anything else, if we can't factor anymore or at all, we're going to try the quadratic formula, which is right here. I realize I wrote it earlier, not thinking about it being right here. Okay, so let's try a few examples really quickly. And I'm going to show you a few different cases. So let's look at number 1. We have a degree 4 polynomial, right? Just like we've said. So I'm going to have you think about this. This is degree 4. And because of that, what we need are 4 solutions. And that's what I'm going to show you how to find. So just reminding you, the very first thing we said about trying to factor, we're not going to graph this today, but the first thing we said to do was check for greatest common factor. So let's try that. The greatest common factor here, if we have one, and I'm checking, it looks like we do. If I look at the two terms over here on the left side of the equation, it looks like we can divide them both by a 4 as well as an x squared. So 4x squared. And remember, we're not getting rid of this common factor. We are dividing it out. We're bringing it out to see what would multiply with it. So 4x squared, divide our first term by that, and we get 1x squared. Divide the second term by that, and we get plus 6. Okay. So we brought out our greatest common factor. We see a binomial here, and we see x squared plus 6. So we can't, if you think about it, we can't do anything more with this because x squared plus 6, I know the square root of x squared. I do not know the square root of 6. So that already stops me there. But also, if we're talking about the square root formula, the difference of squares, this would have to be a minus sign in between. So look back at that. With difference of squares, we only had the option for minus. Okay, so let's try this out then. If I can't factor anymore, then what I need to do is I need to take the factors I already have and set each of those equal to 0. So we have a 4x squared and an x squared plus 6. So let's look at those. We're going to take our 4x squared, that first factor that we brought out, set it equal to 0. We'll bring the x squared plus 6 and set it equal to 0. And now we're going to solve. So on the left side over here, we could divide by 4. If we do that, we get x squared equals 0. And even though I'm about to get the same answer, what we can do is we can solve this, but I want you to understand first is that it says x squared, which means that this equation should have two solutions. So to solve this, all we need to do is take the square root of this side and this side. And something we haven't really practiced before, but you might have seen it in some examples that you've looked at in the past, is when you take the square root with this x squared, your answer on the other side is supposed to have two solutions, and we represent that by putting a plus or minus sign down, and then we just figure out what that square root is. Okay, so for x, we get x equals plus or minus square root of 0 is just 0, and that plus or minus represents the two answers that we are supposed to get. But if you think about it, there is no such thing as a positive 0. Positive 0 and negative 0. So what we get here, this is what it would mean. And we're just going to understand that means that x equals 0 twice. So x equals 0. And we're going to call that a double root because we got that answer 2 times. Okay? So there's 2 of our 4 answers that we're looking for this polynomial. So that means the other 2 must be coming from the second case, which we expect because it has an x squared, meaning 2 solutions. So let's go and try that. Kind of like we did the last one. We can subtract 6 on both sides of the equation. That gives us x squared equals negative 6. And just like before, to solve for x squared, we take the square root, and when we do that, we get x equals, we put the plus or minus sign down to show our 2 solutions, and here's a negative 6. And if you remember, square roots of negatives do something special. We couldn't technically take the square root of a negative value until we learned about imaginaries. And so this is just plus or minus I square root of 6. Okay? And from that, we could realize that means x equals positive I square root of 6, but also x equals negative I squared of 6. And we can either write them all out separately like this or leave it as that plus or minus scenario. And we leave the square root of 6 because it does not break down in its prime factorization to where we can simplify. Meaning our final solutions here are those three values we found. We put 0, and we have the positive I squared of 6 and the negative I squared of 6, and it is okay to just leave those as the plus or minus, as long as we understand that plus or minus represents two solutions, these two solutions right here. Okay, so that is a case of, and actually it's a fairly basic case. As these polynomials get larger exponents, there can be a lot of work involved, but with greatest common factor, there's not always a lot of work to do. Okay, so I wanted to look at another case here, the x to the fourth minus 29x squared plus 100. Notice it has three terms, right? But also notice about it, it's a degree 4 again. So here again, we see that there is a degree 4 polynomial. Let's put that in blue. Degree 4 polynomial. So degree equals 4, meaning we need 4 solutions. Okay. So right here, let's look at that. We have 3 terms in this polynomial. And remember, with 3 terms, that's a case of where we try to do what's called split the middle. And so what we're going to try to do here is figure out what two numbers we can put here that combine back to negative 29. But it can't just be any numbers that do that. They also have to fit the bill on that other case. So with x to the fourth minus 29x squared plus 100, since it is a 3-term polynomial, we can set up our chart that had the multiply side and the add or combined side, whatever you want to call it. And on the multiply side, we take a times c. On the add side, we just look at the value of b. So a times c here, a is 1, all right? We have a 1 x to the fourth, and c is positive 100. 1 times 100 is that. And b is negative 29, so we need that. All right. Now down here, we need to figure out what numbers that would multiply to 100, but also add to negative 29. So think through, we have to multiply to positive 100. So that already has an implication. Either we need 2 positives or 2 negatives. In this case, we're going to use 2 negatives. So we could try things like negative 1 times negative 100, which will not combine to that. So you just keep going. Try negative 2, negative 50. No. And you can keep on trying. I'll go ahead and write these out. So here are all of our possible integer values that would multiply to 100 here if they're both negative. And you notice just one of them gives us that negative 29. It's if we use a negative 4 and a negative 25. Okay, so when we split the middle here, we're going to get negative 4 and negative 25. Now, remember, these have to combine back to negative 29x squared. And so when we split the middle like this, in the past we just put x. But now we have to put x squared if this is the case, because a negative 4x squared minus a 25x squared gives us a negative 29x squared. So we really need to pay attention to our exponent. At the beginning and the end, remember, those stay the same. So what do we get? We have x to the fourth in the beginning. We have the plus 100 at the end. Technically, this all equals 0, but let's not worry about that until just a little bit. So let's keep going. We have 4 terms on the left side now instead of 3, and that is when we looked at grouping. So you looked at the first half and the second half. And the question then became, what do the halves have in common? So what can we take away from each of these halves? Okay, so let's check this out. We have the first half that can be divided by, you notice they both have an x, but if you look closely, we can actually take an x squared away from both, right? So let's go ahead and do that, where we get x squared times x squared minus 4, okay? And then on the right side, a little similar there. We could take away, let's see, whatever we divide by needs to give us an x squared minus 4. And so we're going to need to divide by a negative. One way we can remember that is because this starts with a negative. And if you think about it, for just a moment, if you divide by negative 25, here's what we get. We get x squared here, good. And we get 100 divided by negative 25, which is negative 4, also good. So notice that our parentheses are back to matching, which is great. That means for us, we can now write our factored form, where one of those factors is already in parentheses, the x squared minus 4, and the other factor was our greatest common factors that we brought out, the x squared minus 25. And we are doing well. Okay, so all of this is still equal to 0 because we're solving an equation. And we have two options. We can set these equal to 0 and do our little square root method that we had going on over here. Or we can realize that these factor some more, because if I look inside these first parentheses, I know the square root of each, right? I know the square root of both of these. And look inside these parentheses, I know the square root of both of those too, right? So we could factor a little farther. This one actually breaks down a little bit. Since we know the square root of both, I know that these two parentheses are going to show up where one's a plus and one's a minus. And they both start with the square root of x squared, so they both start with x. And they both end with the square root of 4, which is 2. Okay. In the other case, we have x squared minus 25. We know the square root of both of those as well, so this one also breaks down to those two factors, where one has plus, the other has minus. And again, if you check it out, you take the square root of the first term, so the square root of x squared is just x. And square root of the second term, square root of 25 is 5. And again, all of this equals 0. So what we need to do right now is we need to set each of these equal to 0, which actually ends up being pretty simple. So take each of your 4 factors, the x plus 2, set it equal to 0. X minus 2, set it equal to 0. X plus 5, set it equal to 0. And x minus 5 equals 0. So we just took each of our 4 factors, set them equal to 0, meaning we're going to get an answer from each, our 4 solutions that we said we needed a while ago. So on these, fairly simple, just subtract 2 on this one, and we get x equals negative 2. Add 2 on this one, x equals positive 2. Subtract 5 here, x equals negative 5. And add 5 here. So x equals positive 5. There are the 4 solutions that we wanted. We can write them all out. You can put them in order if you want to practice that, starting with negative 5, then going to negative 2, then positive 2, and then positive 5. If you're wondering if we can write these as plus or minus values like we did on the last one, the answer is yes. You could write it as like this, plus or minus 5 and plus or minus 2. That is up to you. That is not something you have to practice, but if it's something you want to try, you can. And these, of course, are what x equals. So like I said, they get a little bit messy as we get higher exponents. But let's go ahead and try to look at another way to solve that same equation. So if you look at number 3, it's the exact same equation as number 2. So we already know the answers. They're that plus or minus 5 and plus or minus 2. So how can we solve this by the quadratic formula like it says? Well, if you remember that quadratic formula, it has A and B and C in it. So let's go look at it one more time. Quadratic formula right here in the middle of the page. There's A's in a couple spots, B's in a couple spots, and C in just that one location. If we have those 3 values and only those 3 values, we can use this formula. We just might need to alter it a little bit, because as you notice here, it says x equals. But let's go ahead and try that. So when you look at number 3, you see that it starts with a 1x to the 4th. And so things that we know, first off, the degree is 4. Let's keep this in mind over and over. So we need 4 solutions. So need 4 solutions. Okay. So if we've done quadratic formula before, we already know how to work through it, meaning we can still handle this. We're just going to alter it slightly. So the first thing to recognize was A is 1 from this polynomial. B in the middle is negative 29. And C is positive 100. And so let's go ahead and get that formula set up. It was, again, remember, x equals, let's start with negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, okay? And again, we have a and b and c from our polynomial. We can put these in. Now, here's the one thing we need to watch for is not keeping this as x, but in this case, calling it x squared. And the reason for that is because this. We have an x squared as our middle term. And that is actually what this quadratic formula is going to be based on. It's always what does the middle term say? So if we have x squared, we need to make sure this says x squared equals. Okay, so let me show you how that works out. In this formula, if we start substituting in, we get x squared equals negative b, so that is a negative 29, plus or minus the square root of b squared, so that's a negative 29 squared, minus 4 times 1 times 100. So 4 times a times c, all divided by 2a, which is 2 times 1. Okay, let's keep going here. So we get x squared again equals, and let's simplify a little bit. The beginning here is going to be a positive 29. After that, remember, you can type all of this underneath the square root called the radicand. We can type all of this into a scientific calculator to get that. So let's type in the square root, not the square root, let's just type in negative 29 squared using parentheses minus 4 times 1 times 100. So go ahead and try that on your own, and if you do, you should end up getting 441. If not, check that you see you typed everything in and that you use parentheses around this negative 29. Okay, the bottom, 2 times 1 is 2. Perfect. All right, keep going from here. Simplifying again, we have x squared equals 29 plus or minus. Good news with this square root of 441, it is a perfect square, so we get 21 from that, all divided by 2. And then we break off. Remember that plus or minus is 2 cases. We have x squared, and make sure you keep this x squared. We're going to need it. We have 29 plus 21 over 2. And we also have x squared equals 29 minus 21 over 2. Okay, and solving that, we get x squared equals, that is 50 over 2. Fix that, 50 over 2. And x squared equals 8 over 2. So we get x squared equals 25, and x squared equals 4. And just like we saw on the front page, we can take the square root of each of these. And so we can take the square root of x squared. Now remember, x squared is supposed to have 2 solutions. And so as we do this, we get x equals the plus or minus the square root of 25. And so in this case, we get plus or minus positive 5, which if we choose, we can write out separately as x equals positive 5 and x equals negative 5. So there's 2 solutions. And up here, same deal. We take the square root of each side of the equation, and we get x And remember, x squared is supposed to have two solutions. So here's the plus or minus to show that. We'll determine the square root of 4, and it is 2. And again, you could write those out as separate solutions if needed. And there they are. They're the same solutions we saw on the front side of the notes for number 2, which was the same example. But also, there's 4 solutions, just like we said we needed, because this was a degree 4 polynomial. When we write these out, you can write it in the plus or minus form. So plus or minus 5 and plus or minus 2 in your solution set. Or you can write the 4 solutions out individually. And again, standard practice would be start with your lowest solution and work your way up to your highest. Okay, so there's a few examples, and if you haven't had enough fun yet, let's try one last one. And if you look at this one closely, it's a little bit different, right? It has degree 3. We see an x to the third as our highest exponent, so this one is degree 3. That means we need not 4 solutions, but rather 3 of them. And something interesting happens in this one, so stay tuned, follow along, and you'll see what I'm going to show you. But this is one of those special cases that we didn't finish on the front, where we have 2 terms, and one of them's x cubed. And so what we're going to end up using is one of these cube formulas, and in this case it's going to be the one I showed you earlier with the plus sign, because that's what our polynomial uses. So we are going to factor this as these parentheses shown by using our a and b values. Okay, so let's give that a try. On number 4, first off, we're going to need to know how this factors. And so the factors that we need are going to be a plus b times a squared minus ab plus b squared. And that is just straight from the formula. So I'm keeping that in mind as we approach this one. Okay, so everything's based off of a and b. And to get a and b, if you remember, it's pretty simple. Instead of taking square roots, we're going to take cube roots. And so we're going to take the cube root of x to the third, or the cube root of x cubed. And good news is, very little work to be done there. It's just x, okay? It's nice when these the roots match the exponents. So cube root matches x cubed. Fourth root would cancel x to the fourth, even though that's not something that we've seen. Okay, so we have a. Anywhere we see the letter a, we'll replace it with an x. So remember, b is going to be the cube root of your second term, so the cube root of 125. And you can either reason through in your head what number times itself again gives you that 125, or pull out a scientific calculator, type in the cube root of 125. It's going to tell you 5 for that reason that we've said. 5 times 5 times 5 equals 125. Okay, so now that we know what our a and b values are, we can go ahead and set up this formula. You see it over here. It starts with a plus b. And so for us, that's going to be x plus 5, right? A is, we figured out, was x, and our second term gave us 5. And then after that, it says a squared. So we go back to a. We're going to get an x squared minus sign a times b. So x times 5 plus b squared. So that is 5 squared. And let's just convince ourselves that we did it right. Here's an a, here's a b, here's an a squared, here's an ab, and here's a b squared, right? So it looks like we put everything in the right places. Now we want to simplify a little bit. So we have x plus 5 times x squared minus, we should really reverse the order there. We more commonly write this as 5x. And then we know 5 squared is the number 25. And then keep in mind all of this is equal to 0. Okay, so let's check this out. We said we need 3 solutions because it's degree 3. Well, where are they coming from? Well, this one has x to the second, so 2 solutions will come from this. This has x to the first, so the other solution will come from this. So let's go and see how that happens. This first one, we simply just take x plus 5 and set it equal to 0. Pretty easy here. Subtracting 5 tells us that x equals negative 5. Okay. Now let's try this other scenario. Okay, so something that you need to keep in mind as you go. There's a limitation with this formula. This does not break down at all, and it never will. Anytime we use this formula, this trinomial never breaks down. And it does not, so it won't factor. And the reason for that is the solutions are imaginary. And actually, more than imaginary, they're probably going to involve a square root, which is why we can't factor it. Okay, so the solutions we're about to find here wouldn't show up on a graph. If we graph this thing, we're going to see it has an x-intercept at negative 5. But we're going to see that's the only x-intercept that's present. And we are supposed to know that this is supposed to have 3 solutions because we have a degree 3 polynomial. So how can we solve this quadratic if we don't have, if we can't factor it? Well, if all else fails, we try that quadratic formula, remember? So we're going to try this again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay? And look at that. I put x equals. I didn't put x squared equals because my middle term just has an x. And that's what it's always based on. All right, so let's substitute. In this formula, we can see that a, not to be confused with this other a we were talking about earlier, but a, b, and c at this point are just looking at our coefficients inside. So for x equals, we get negative b, which is going to be a negative 5, plus or minus the square root of b squared, so that is negative 5 squared, minus 4 times a times c. And I'm about to run out of room, so let me rearrange this. Okay, so got that fixed. We have minus 4 times 1 times 25 under there now, and we're dividing by 2 times a, so 2 times 1. Let's simplify this a little bit more. Negative 5, that is 5, plus or minus the square root. And underneath, we can type all of this into a scientific calculator at one time. Make sure you put parentheses around the negative 5. Go ahead and try that. And if you do, you should end up getting negative 75 all over 2. Okay. And let's see what else we have. So we have x equals. Let's simplify that square root. So first off, remember, a negative square root of a negative, that is, gives us an imaginary result. So we know it's going to be imaginary, just like we thought it would, because we only saw there was only one x-intercept in this graph if we had graphed it. Okay, and so if you remember, square root of 75 breaks down. If you want to see that here, 75 is, let's see, what is that? It's 3 times 25, and 25 breaks down to 5 times 5. And so from that, we have a pair of factors here that will come out, and the 3 will stay underneath. And we end up getting x equals 5 plus or minus 5i square root of 3 all over 2. And that is as far as we can go. I think if we check that out, we get 5 over 2, which does not reduce, plus or minus 5i squared of 3. Let's rewrite that. Let's put the I at the end. So we get 5 squared of 3 over 2 times I. Okay, so in this case, we see it does not reduce. And it'd be just a mess to try to write all this out. So write these out as separate answers. So when we go to the end, very typically, here's all we're going to put. We're going to put that x equals. Okay, change that there. X equals. And let's just put what we know. We know that we had an answer of -5 from earlier. And rather than writing these imaginary solutions out separately, it's okay to just leave it as this. So just make a fraction and leave everything in the top up there. And in the bottom, we just have a 2. So sometimes these will reduce, but we see here that we were not able to. Okay, and that's where we're going to leave it here, because these things can get really tricky, but we're just getting used to the idea. So use these strategies to your advantage, try them out, and see what you can come up with.